In this lecture, we will be discussing the tools and techniques of the plan quality management process. The tools and techniques for this process include expert judgment, data gathering, decision making, data representation, test and inspection planning, and meetings. Let's discuss them briefly. As part of expert judgment, expertise should be considered from individuals or groups with specialized knowledge or training in topics like quality assurance, quality control, quality measurements, quality improvement, and quality systems. The data gathering technique that can be used for this process of plan quality management include benchmarking, brainstorming, and interviews. Benchmarking involves comparing actual or planned project practices or the project's quality standards to those of comparable projects to identify best practices, generate ideas for improvement, and provide a basis for measuring performance. Benchmarked projects may exist within the performing organization or outside of it, or can be within the same application area or other application areas. Benchmarking allows for analogies from projects in a different application area or different industries to be made. Brainstorming can be used to gather data creatively from a group of team members or subject matter experts to develop the quality management plan that best fits the upcoming project. Project and product quality needs and expectations, implicit and explicit, formal and informal, can be identified by interviewing experienced project participants, stakeholders, and subject matter experts. Interviews should be conducted in an environment of trust and confidentiality to encourage honest and unbiased contributions. Data analysis techniques that can be used for this process include cost-benefit analysis and cost of quality. A cost-benefit analysis is a financial analysis tool used to estimate the strengths and weaknesses of alternatives in order to determine the best alternative in terms of benefits provided. Cost-benefit analysis will help the project manager determine if the planned quality activities are cost-effective. The primary benefits of meeting quality requirements include less rework, higher productivity, lower costs, increased stakeholder satisfaction, and increased profitability. A cost-benefit analysis for each quality activity compares the cost of the quality step to the expected benefit. The cost of quality. The cost of quality associated with the project consists of one or more of the following. Prevention cost. These are the costs related to the prevention of poor quality in the products, deliverables, or services for the specific project. Appraisal costs. These are the costs related to evaluating, measuring, auditing, and testing the products, deliverables, or services of the specific project. And then we have the failure costs that can be either internal or external. These are the costs that are related to non-conformance of the products, deliverables, or services to the needs or expectations of the stakeholders. The optimal cost of quality is one that reflects the appropriate balance for investing in the cost of prevention and appraisal to avoid failure costs. Models show that there is an optimal quality cost for projects, where investing in additional prevention or appraisal costs is neither beneficial nor cost-effective. A decision-making technique that can be used for this process includes multi-criteria decision analysis. Multi-criteria decision analysis tools can be used to identify the key issues and suitable alternatives to be prioritized as a set of decisions for implementation. Criteria are prioritized and weighted before being applied to all available alternatives to obtain a mathematical score for each alternative. The alternatives are then ranked by score. As used in this process, it can help prioritize quality metrics. Data representation techniques that can be used for this process include flowcharts, logical data model, matrix diagrams, and mind mapping. Flowcharts are also referred to as process maps because they display the sequence of steps and the branching possibilities that exist for a process that transforms one or more inputs into one or more outputs. Flowcharts show the activities, decision points, branching loops, parallel paths, and the overall order of processing by mapping the operational details of procedures that exist within a horizontal value chain. Flowcharts may prove useful in understanding and estimating the cost of quality for a process. One version of a value chain known as the PMBOK model is shown in the figure in front of you on the screen. Information is obtained by using the workflow branching logic and associated relative frequencies to estimate the expected monetary value for the conformance and non-conformance work required to deliver the expected conforming output. When flowcharts are used to represent the steps in a process, they are sometimes called process flows or process flow diagrams, and they can be used for process improvement as well as identifying where quality defects can occur or where to incorporate quality checks. Logical data models are a visual representation of an organization's data, described in business language and independent of any specific technology. The logical data model can be used to identify where data integrity or other quality issues can arise. Matrix diagrams help find the strength of relationships among different factors, causes, and objectives that exist between the rows and columns that form the matrix. Depending on how many factors may be compared, the project manager can use different shapes of matrix diagrams. For example, L, T, Y, X, C, and roof-shaped. In this process, they facilitate identifying the key quality metrics that are important for the success of the project. Mind mapping is a diagrammatic method used to visually organizing information. A mind map in quality is often created around a single quality concept, drawn as an image in the center of a blank landscape page, to which associated representations of ideas such as images, words, and parts of words are added. The mind mapping technique may help in the rapid gathering of project quality requirements, constraints, dependencies, and relationships. During the planning phase, the project manager and the project team determine how to test or inspect the product, deliverable, or service to meet the stakeholders' needs and expectations, as well as how to meet the goal for the product's performance and reliability. The tests and inspections are industry dependent and can include, for example, alpha and beta tests in software projects, strengths tests in construction project, inspection in manufacturing and field tests, and non-destructive tests in engineering. Project teams may hold planning meetings to develop the quality management plan. Attendees can include the project manager, the project sponsor, selected project team members, selected stakeholders, and anyone with responsibility for project quality management activities and others as needed.